Hello, everybody, and welcome back. It's me, Cyber Warrior, and this is CyberWarriorStudios, and we are once again live for Tech Tuesday. So, over the past 2 weeks, we've been digging into ParrotSec. So we've done the install, and then last week we covered a little bit of what I go over on a regular basis when I get started. But there's still a few things we're missing. On top of that, I want to go over a non-mode and not necessarily show you how to use it, but explain something that can happen on occasion. So, to do this, let's log in to our Parrot desktop. And let's do IP tables save. I bet you I need sudo. We can't see them because I already fixed it. All right. Anywho, so earlier today, I was setting up for a class in which I was going to use ParrotSec and also Windows 10 Flare to work on buffer overflows, which is something I still want to cover today. I want to go over some of that. There's just some other things I want to do first. And in doing so, I came across a problem. I could ping all day, but I couldn't access the internet. Every time I opened up a web browser and went to go somewhere, go to any website, I got denied. I was even able to run NS lookup, which basically told me that all my name servers and DNS servers were working. I'll tell you what, I was banging my head off a wall for about an hour until I remembered that in ParrotSec, with the non-mode, there are a lot of changes it makes to your IP tables, to your servers, everything. There's a lot of changes that go on. So, after about an hour of deleting IP tables rules and messing with resolve my DNS resolver and adding network cards, removing network cards, finally said, you know what, hold up. I was on and on mode, and I remember this problem. So, I did just that. Pulled up our non-surf GUI again. Now, this right here says a non-surf is not running. It's because I already fixed it. But prior to that, mind you, I have restarted this box. I've done a lot of different things. It was giving me an error. And it was saying a non-surf is not running correctly. Well, I didn't start a non-surf, but sometimes it gets set up to where it wants to start on boot. So if it doesn't activate properly, your rules and everything don't get put in play. And therein lies a problem. Because I was allowed to ping and go over ICMP. I was allowed to use NS lookup. But the moment I went to go over port 443 and execute anything through HTTPS or HTTP, I got denied. That includes using wget, app-get, whatever you want to say. Including all that, I got denied. So when I pulled this up and told it to stop so that there was no misconfiguration in there, I got my access back. So just keep that in mind going forward, that if you're ever messing with a non-mode or a non-surf and you think you turn it off or you restart your computer and something's not working right, more than likely there's some rules or configurations that are still sitting idle in there, that you may either have to stop it altogether, maybe for some reason it still says it started, or just try to start it again and then stop it, and you should get your configurations back. But yes, sometimes the configurations kind of get stuck, it doesn't fully shut down right, and it gets stuck in kind of this limbo, which can mess up a lot of things. So keep that in mind. Now that we're done with that, and we've covered that, let's go ahead and clear our screen. Now, I don't know about you guys, but when I first started getting into security and ethical hacking and things like that, one of the first things that I was taught, besides Nmap, was Metasploit. Now, mind you, you are not allowed to use Metasploit but once on the OSCP, and even then, every exploit in there, unless you find ways to disguise it, right? Whether it's through encryption or whatever for your payloads, just about everything else in there has signatures for it. Which means if you're using a signature-based anti-malware solution, it's going to get caught. So Metasploit's not the best thing to use unless you're a pen tester. Granted, some APTs and some other groups out there still use Metasploit or Cobalt Strike or things like that. But if you can do it on your own or find something on GitHub or whatever and just rework the code to change the signatures, then you're better off. But as far as Metasploit goes, yeah, you can use it out the box. I can sit here and say MSF console and hit enter. And it's gonna work. It'll start up. But it should kick back a few warnings as soon as it's done. So let's go up here. Where did it? It didn't kick the warnings out it used to. Alright. Let's see if we got DB status. So I have no connection to a database. And databases are important within Metasploit. Hey, hacker, how's it going, man? Welcome. Thank you for joining us. But databases are important, especially as a pen tester. It helps you keep your information isolated into different environments and different places and workspaces and things like that so that you don't have contamination of data. So if you're working on Try Hack Me and Hack the Box and whatever else, you can have different workspaces for each. If you're a pen tester and you're using things like MSF Pro or even open source Metasploit community for your pen testing, again, not out of the question, because when we're in a time crunch, we ain't got time to do a bunch of searching and rescripting and recoding. You know, you're held to a certain amount of hours during a pen test. So when you're in that, Metasploit's still a great place to go. It's good to have information isolated. All right. So we can't do that right now. I could type in workspace, but things will get told I have no database to have a workspace. All right. So how do we fix that? Well, it's quite simple, really. First, let's see if Postgres is started up. Sudo service PostgreSQL start. Alright, so now we have Postgres running. Postgres is a SQL database that is used by Metasploit, and it's installed by default on ParrotSec, Kali, and a lot of other offensive security distributions. Alright, cool. So Postgres is started. So then the next thing we do is MSF DB init. Okay. Sudo MSF DB init. Database is already started because I already started it. Creating the users. And the default password and user and everything gets generated. And it should just be MSF, and I think MSF for the password. But in the case of what we're going to do, we don't need it because we're not really going to attempt to log on to the database itself. We're just creating this connection and configuration for it. So now, if we go into MSF console, cool. We go with, and yes, it says kernel panic. Please do not be worried. These are just different ASCII arts and things like that Rapid7 has built into Metasploit. No, your system isn't dying. All right. Even in that code, you can see it says Metasploit framework version 5. Even though we're on version 6, so they haven't updated that yet. So now if I do DB status, hey, we're connected. Connection type Postgres, connected to MSF database. And if I do workspace, I'm in the default. Cool. So what that means is if I go in and did like an nmap scan on something, host, I want to see host, is it? All right. Yeah, this also is able to list your hosts and everything else. So what if we want to add a workspace? Workspace dash add, I believe. Let's do dash H. Yeah, dash A. So workspace dash A. We'll call this one CWS for CyberWarriorStudios. Cool. Now if I do workspace. All right. As soon as you create a workspace, that becomes your active workspace. So if you want to go back to default, you would say workspace, I believe, default, and then do workspace again to verify, and now you're in the default workspace. If we wanted to delete a workspace, it's just workspace -D CWS. Cool. Now it's deleted. No longer there. And again, these workspaces, and a lot of people don't know about this, especially those that are just getting into Metasploit or have just, you know, recently been working on Hack the Box or Try Hack Me or Virtual Hacking Labs or whatever the case may be. They don't know about workspaces, so all their information, all their different things get kind of convoluted. Understand that there is a lot you can do with Metasploit. And now this isn't going to be an entire Metasploit class. However, you can run Nmap from Metasploit. And that way, instead of maybe running it outside of Metasploit and then importing your results, by running it straight from here, it will actually take all its findings and automatically put it in the workspace. So if we create that workspace again, and we'll just do this real quick so you can see. Hosts, I have nothing. But let's do, I believe it's DB Nmap. And we're going to say 192.168. Just so, yeah, 111.128. We're not going to do anything extravagant. We're just going to see what's there. All right, cool. So did a basic Nmap scan. And then we're just going to do hosts. Now, in there is 192.168, 111.128. Unknown because I didn't do an OS detection. And purpose is just a device. Now, if I were to go further with it, then you would see that it is my Windows 10 Flare installation. And if this was up and running, actually still listening, you'd have a listening connection on port 31337, a lot of other things. But yes, it's amazing what you can do with this. Hey, good evening, SecCon. So anybody who has done anything with Metasploit, you know, I guarantee you there's still more about it that you don't know. And this is just one of those things. Setting it up is setting up the database, making sure Postgres is started, making sure you have your separate workspaces and things like that. So that's getting into Metasploit. And the reason I wanted it set up and show you guys how to set it up is because I'm going to go through a script that I have steps in for a buffer overflow. Now, anybody who has ever who hasn't looked at buffer overflows yet, yes, there's really advanced ones. All right, so you can get into, there's stack-based buffer overflows. There's buffer overflows where you're trying to avoid depth. There's buffer overflows where you're trying to avoid depth and ASLR, or just ASLR, or stack canaries. There's a bunch of them. What we're going to look at is actually just a 32-bit stack-based buffer overflow. And if you haven't looked at Justin Stevens' Do Stack Buffer Overflow Good, it's actually exactly what this is. So his verbiage, he could probably go more in depth about the assembly and how the registers work and things of that nature. I'll be honest, I learned just enough to be able to do them at a very, very basic level and design a script that will allow me to exploit standard stack-based buffer overflows. But for anybody who hasn't done it, get to see something pretty cool, or at least I hope you think it's pretty cool, because it'll actually show you that with a debugger, all right, which I'm using Immunity, and I have Mona built in, or I have the MonaPy add-on. So with Immunity and Mona, and then his executable, we're going to go through and overflow it. And we're going to go a little bit step by step on how things are done. I have the code built out, and I have the different steps in there and why you do certain things. So, and the nice thing is we're actually going to use our interpreter reverse shell so that you get to see the interpreter in action once we get it running. Now, mind you, for this, and I have all of my antivirus turned off on this Windows variation or version. So that way you guys can actually see this work. And we're going to go through and look at it a little bit. Have any of you actually done buffer overflows yet? I'm sure some of you may have, but have you all? No. All right, so we got one no. All right, so we've got some, we've got nope. Hopefully, if you have done it, maybe I can give you a different perspective or a different way of looking at it, or maybe explain Justin Stevens in a way you didn't understand it before. And if you haven't done it, you are in for a treat. I'm going to show you what exactly is going on under the covers during a buffer overflow and what those who exploit buffer overflows are looking for, all right, and how they go about doing it. So the first things first, we have from Justin Stevens, let me start this, that way it actually comes up, this program. It's called Do Stack Buffer Overflow Good.exe. Now, on his GitHub repo, he has this huge PDF because he did an entire presentation on this. So if you want to go and get a full overview and tutorial and take your time through this, by all means, do it. But I'm here to answer your questions and hopefully give you a little bit of an understanding that maybe you didn't have before. So again, Do Stack Buffer Overflow Good by Justin Stevens. It is how I studied for my OSCP, among a few other things, but this was the primary that I used outside of offensive security's instruction. So if we go through and we look at this, he has his his intro, but there is a way to rewrite this code for Python 3, but because I was using it on my ParrotSec, I figured I'd just use Python 2 because I have both languages there, so it makes it a little bit easier. I just did Python 2, went through, looked at what he had, and went about my merry way. Optionally in here, if you have IDA or IDA Pro or Ghidra or anything like that, you can actually disassemble his entire program, which he has in here, his explanations of the calls and returns and things of that nature. So, in order to see if we have Mona here, which I do, and I'm going to actually go through and show you guys where to get some of this stuff. But if we go here and just type in Mona, we get this help screen, all right, which if it's hard for you to see, I apologize. Hopefully it's not. But hopefully you guys are seeing this pretty well. But yeah, so you get this help screen. So, all right, cool. So we know Mona is where it needs to be. So before we go further, let me show you guys how to go about getting this. All right, so let me put this in both chats real quick. And github.com. Little small on that screen. Yeah, I was afraid of that, SecCon. I'll pull out the magnifier as needed whenever we get a little bit deeper. Or I can even, actually the PDF, I can show you that because we're going to do a lot of what he does. Let's see. Justin Stevens, Do Stack Buffer Overflow. Good. So I believe that's the GitHub page. Let me copy, paste. All right. So if you want to follow along, I just sent you the link for the GitHub page. So this is what we're looking at. We're looking at his PDF and using his program and his script. Now, granted, my script isn't as clean because I actually have comments in there for at what step we do certain things. That way I didn't have to rewrite the entire thing again. So we'll be able to go about it that way. So moving on down. Let me get you this one too. So if this is for Mona, if you want to put Mona in Immunity Debugger. The thing about Immunity Debugger, and you can use WinDBG too, WinDebug, if you want to. There's a GitHub that shows you how to use it. But if you want to use Immunity, it is free. You just have to put in information, like most sites that want to email you constantly, dumb things. So do with that as you will, but that's how I got Immunity, and like I said, it is free, so it's always nice. And then you just put it in the Pi commands folder. So if you do a standard install like everybody else, or I can't say everybody else, but like a lot of people, and just do next, Immunity Debugger comes under C, program files, x86, and under Pi commands, that is where I have my Mona.py. So that's how we get access to Mona. So hopefully that clears a few things up. Now, we're going to look. See, this is his source code. Has anyone researched what one of the big buffer overflows was within older C code? Because if you did if you've ever done any research on it, you should be able to see it right now. Anybody? Anybody? Going once? Going twice? Oh man, 715. And you're about to learn something really new. Cool. Alright. So it looks like nobody really knows. Which is fine. Even I didn't know whenever I was first learning this. And actually, even after a while, I didn't realize it. But this build response. Oh, live step. Within older C, well, within C programming, before some of the newer functions came out, what was the command module function, whatever you want to call it? My C terminology is a little off, but what is it that has a buffer overflow possibility unless you properly limit your buffer and things like that? Frankenstein, we all been there, man. That's right, Devil Ray. Better late than never. Alright, Live Step might have the answer. Oh, no, he don't know. Alright, cool. Sprint F, if I recall correctly. Because that's actually what we're going to exploit right here. Sprint F has within it, unless you handle your buffer properly, it has a buffer overflow built in. When it was first developed, nobody really knew, but people found it, and for a while they were exploiting that Sprint F module. Devil Ray, off and on, man. I got neuropathy in both my arms, so today it's been hit or miss. Thanks for asking, though, man. So that's essentially what we're going to look at. So now that this is running and we're listening for connections, we're going to go back to our ParrotSec. All right, and we're going to leave that up because I'm actually going to end up using it. We're going to do clear. Do stack. Oh, there it is. So let's pull up this. Close, and do file, open file. Where is it? Do stack. All right. So you're getting a little bit of extra out of this. So anybody who doesn't know Python, guess what? You're going to get a little bit of Python in there too. Unfortunately, it's Python 2. Like I said when I built this earlier today and was working on this for a class that I was putting on, I didn't feel like fixing everything so that it would work with Python 3. So we're sticking with Python 2. If you want to convert it to Python 3, feel free. Like I said, this is everything. I took this stuff straight from Justin Stevens. I give credit where credit's due. I pulled this script from him just because I couldn't find any of my older ones and didn't want to have to rebuild one, so I used his. But essentially, whenever you want to talk to a network, talk over the network in Python, you need what's called socket. All right, so there's raw sockets that you are going to interact with. And this import socket, which is on line 2, if you don't know what line 1 is, that's a shebang, and that says what environment to run out of. We're telling this to run out of Python 2. So if we made this executable and that said Python 3, it would run Python. It would run as if it was in Python 3. But we have it as Python 2, so it's going to run as Python 2. And then line 2 says import socket. That says, hey, I'm going to use these modules from Python, which are other functions and classes and things like that. But we're going to use the socket import. And what that's going to allow us to do is communicate over the network, which is cool. All right, so we have socket here. Now, we don't know what we're going to do with it yet, so let's go down a little bit further. The next set of lines, all right. Now, Justin Stevens, much like myself, because I do the exact same thing, comments all his code and lets us know what's going on. So the next comment says, set up the IP and port we're connecting to. If you've dealt with Metasploit at all, then you will see quite frequently our host and our port. Remote host, remote port, right? So that's what you're connecting to. So my remote box is 111.128. And the port that this application listens on is 31337. Yes, Justin Stevens is a jokester and used lead speak for shits and giggles. So 31337 is the remote port that we're going to connect to. All right, cool. So let's move on down a little bit. All right, now we need to create a TCP connection. We need to open up that socket. So how do we do it? Well, one, we have s equals, which is basically declaring another variable. So s is going to equal socket.socket, and then socket.afinet, and socket.sockstring. Now, you can go and look at the documentation for Python and Python sockets, but essentially, it's taking that socket and setting up an IP address and a stream for it to connect to. Now, if you didn't have that s equals variable there, you would have to type that out every time you wanted to connect or you wanted to issue this connection. So for us, we're saying s equals this. So that way, when we go to the next line, we can say, hey, use this socket and connect to our remote host and our remote port, which in our case is going to be that .128 and 31337. All right, so we're looking good, right? Next, we want to build a happy little message followed by a new line. So we begin our buffer, all right, and we put nothing in that first string. Then, anybody who knows anything about variables, and if you don't know about variables, I'll tell you something right now. If for that next line where it says buff plus equals Python script, if that just said buff equals Python script, it would overwrite the buff variable before it. But since that plus is there, it adds to it. All right, just like you're incrementing. Only instead of plus plus, where you're going to increment one, some variable, you are essentially just adding to that variable, or amending, or pending, correction. And then you have buff plus equals new line, which is essentially the enter key. All right, cool. So we've got a variable there. Nice. All right, that's going to be our buffer. So that is what we are going to send. So that, once again, we have that s variable, which is that socket.socket, and we are going to send whatever we have in buff. All right, so whatever's in our buffer. Once we do that, we're going to print what we sent, and then we are going to receive back from that connection, because if you connect to this and send something, it's actually going to send something back to you. All right, so what is it we're going to send? What we're going to see, and then we're going to print out what we received. All right, so that's what we're going to do. Let's see what happens. So if we go here, and in my case, I already did change the file to executable, but let's say you save that. Instead of, if you didn't want to have to run Python and then your file.py every time, all you would do is chmod plus x, and then my file is this dostack.py. I've already done it, so we're not going to do it again. So we'll do /dostack.py, hey, I sent Python script and I received hello Python script. That's awesome, right? So I sent something, I received something. So this program is basically saying, okay, whatever I receive, I'm going to send that back, that exact same string. All right, it's going to be hello, whatever string you sent it, and then exclamation points. All right, but what does that have to do with immunity and, debugging the program? Well, a lot, right? So we're going to go here. And I don't need that anymore, but I do need this. And we see it's still running. So let's go here. And I've already explained what's going on. Now, if you don't know immunity, let's take a look at this real quick. That way you guys can get an understanding of the way immunity is laid out. So I do hope this screenshot that I'm sharing is better. On the right side of immunity are our registers. So with an assembly in memory, that's our instruction pointer, our base pointer, our stack pointer, all of our registers within our CPU. And then over here we have our disassembler. So if you were to take this program and put it in like IDA or something like that, that's where you would see your disassembler. All right, so that's all your assembly code. Then you have your hex dumped on here, and whatever is sitting on the stack is over here. Which, is pretty awesome. So, we already remotely interacted with the process. We already did this one. So well and good, but, we want to see exactly what's going on. Now, again, if you want to do this on your own and get a better explanation of the assembly, please feel free. All right, go ahead, go to Do Stack Buffer Overflow Good. By Justin Stevens. Go through his PDF, and he can explain everything in a lot more detail. I just don't have the time for it today. And to be completely honest, he probably explains it better than I can. But if you have questions, feel free to ask. So, but what I want to see is 804, where did I say that was? 804.168D, which is going to be the call. 804... 168D all the way up here. 68D. All right. So we want to put a break on that, and what I'm doing now is putting these breakpoints in, so that you can kind of see what happens. 804.1794. Thanks, Infinite. 804.1794. 804.1794. Whoops. Right there. F2. Alright. So, now that we have those, let's go back. So we have these breakpoint in. Let's see what happens. So if I send this, I didn't receive anything. What happened? Alright. So what happened was, we have breakpoints that actually stop the code. Alright. So it hits this point in the memory, in the CPU, and it stops. Alright, right there. But that's awesome because we get the ability to take a look at what's on the stack at that point in time. So we can see here, and let me get this magnifier. You know what? Hopefully you guys can see this. I'll be honest, when I magnify this stuff, it looks kind of ugly even to me. So hopefully it doesn't look too bad to you guys. But it does look ugly. Yeah. I can barely read that. Hold on. Let's see if I go. I can either do 125 or 150 or 100 or 150, so it's not worth it. All right. So let's pull up the PDF. So we did this break, and we can see Python script. So we see that we got a breakpoint. All right. You should be able to adjust the font. Can I? View. Window. Options. Appearance. General. Color. Fonts. +5. It's a little better. Can I go higher? All right, so +5 is all I can do there. That's 7. +5. Hopefully that's a little clearer. But yeah, it still looks kind of small even to me. Control plus. Not on this, but yeah. Nope. Well, hey, if you find it again, let me know. Because I know this is a little bit small for you guys. But if we look at the EIP, we're at 0804168D. And again, we're going to skip that part. Well, we're not going to skip it. I'm going to go to his... let me pull this open. Alright, so we got our breakpoints in. So you can't really see on my screen in my immunity because of how small it is, but here's a screenshot that he has, so hopefully this looks a little better, and mine looks exactly like this. So we set our breakpoint on the call, and in there you have your Python script that we sent in your on the stack, which is awesome. Alright, cool. So we can interact with the stack, we can do these different things. And you can step into, I believe that's this one. Or is that step through? There it is. So we can see what it's doing. All right. Right click top left pane and a menu will appear. Choose appearance, font all. Right. Appearance, font all. Oh, that is bigger. Ah, nice. Donka. Alright, so hopefully that's a little better for you guys. Thanks, Infinite Logins. That's awesome. Learn something new every day. Alright, so we step through all this and we get all of our fun stuff. But what if I hit F9 and play through? I hit another breakpoint. So our breakpoint here has the EIP at 8041794. Which is this next move where it's going to move the base pointer into the stack pointer. So it's going to take this right here and move it to ESP. And then let's play. All right, play. Dang it. F7. Did I break it? What are you doing? All right, client disconnected. Screens are already sent. So go here. Yep. All right, cool. So we finish off the script. Alright, that's all well and good. We could send hello Python script all day and nothing will happen, right? It doesn't really look very fun to us. I mean, if it's not fun, why are we doing it? So let's move that breakpoint, get rid of you, go here, hit F2, get rid of you. Alright. We still running? And we're running, and we're running. Alright. So, now we're running. And... like I said, this is about buffer overflows. So how are we going to do that? Well, let's go back here. So let's take a look at this fun little script. Which, mind you, we are going to change out this shellcode. So I'm going to actually remove all of this. A, because it's eating up memory being there. And B, because I don't need it yet. And it just takes up space. And we want to get rid of you. Whoops, wrong thing. You. Sorry about that, guys. Kids got a little lot. Had to mute the mic for a second. So, let's take this one out. And you're like, oh my god, there's so much comments, I can't make sense of it. But that's why I put comments above everything. So, as we go down, we see that step 1, find buffer overflow amount. Now, you can find so many scripts out there and that'll do fuzzing for you. And what that does is essentially sends a ton of different character sets in different and varying amounts, or in incremental amounts, to an application to find out where it breaks, or if it breaks at any given point in time. But Justin Stevens is nice enough to tell us, let's send 1024 A's to this program and see what happens. All right, so that's what we're going to do. So we're going to save this. And we're going to go here. And we're going to send this exploit dostack.py. All right, let's send it. I ain't getting any response. What happened? What did I do? Oh, no. Well, let's find out. So we're going to go back here. Hey, Cyber Panda. Bang, bang, Panda gang. So we're going to go here, and we're going to see that ESP and the stack pointer is all A's. But not just that. In our instruction pointer, in EIP, is 41414141, which is effectively AAA. And then in our base pointer, we have the same thing. 41414141. AAAA. All right. So, and you can see down here it's paused. So we're paused here. We've got nothing. It's not ready to receive anymore. All right. Bytes received 1025. Send failed because it crashed. There was not. It couldn't send anything. So, and when you see the pause in immunity, that means it crashed. All right. That means we broke something. Let me explain why it broke. Your instruction pointer points to the next part of memory that it needs to execute. So this right now is saying, hey, my next instruction is at 41414141. There's not an at 41414141. So there's nothing for it to execute. There's no piece of memory for it to grab, nothing for it to do, so it dies. And if we look at Justin Stevens, and he gives a little bit of an explanation here, trigger the bug. So here's his code. 414141. Crashy, crashy. He likes to, call crashy, crashy. So we get an access violation when executing 41 and the presence of 41 in the EIP register. 41 is the hexadecimal value of the ASCII character A. So we know we have overwritten the saved return pointer with 4 of our 1024 A's. So you can do breakpoints and figure out what happens and, this, that, and third, but we already know. We overwrote it. All right, so got you. It's overwritten. So now what do we do? Well, now we go back to immunity and we say, you know what? I want to restart. So we're going to reset this and re-execute it. Done. And we're going to say play. All right, so we're running. All right, so we are running again. We are up and running. Nothing on here. We're just listening for connections. Well, that's awesome. All right, so let's listen for these connections. And we're going to go back to our code. So, all right, so we know 1024 is what we need to do this. But you know what? That was step 1. Step 2, we need to find an offset. All right. Well, there's a few ways you can find an offset. If I had Python 2 installed on Windows or had rewritten this code for Python 3, I would show you the way to develop that offset through Mona. But I didn't do that. So we're going to do it through Parrot. Where are we at? So we're going to use a good old Metasploit tool called pattern create. And what this does, it creates random 4-byte patterns. Cyber Panda, I'm using immunity with Mona. You can also use WinDBG with Mona. And I like those two because well, Mona is amazing, and you'll see why here in a minute. So, yeah, so we run pattern create -L, which tells us the length of the pattern. 1024 bytes, because that's what we were using, right? So, understand that their pattern create Ruby script for every number of bytes will create the exact same pattern. So I can go through here and change it or like copy and paste this code into exploit here, but I have no need to. All right, I already have it, so we're gonna use it. All right, so now instead of sending 1024 A's with a new line, we're going to send this pattern. And the point to sending this pattern is we want to find at which point we are overwriting EIP. We want to know when we are overwriting that instruction pointer. That way, when we go through and have to tell the code where our next instruction is going to be, or rather where jump ESP is going to be, and we'll get to that point, we know exactly how many bytes to send first. So we're going to save this. And once again, we're going to come here and we're going to execute this. All right. And we get another crash. As you can see, we ain't get nothing back. So we come here and we see it's paused. We have a crash. So there's a few ways we can go about finding out what the pattern was, like what our buffer is going to be now. All right, where our offset is. So first, we're going to use Mona, mainly because I can't do up, can I? There it is. This Mona find MSP. Is going to, all right, as soon as it runs, still loading. All right, we're done. Cool. So Mona file, whoops, appearance, font, OEM fixed font. All right, it's a little bit better for you guys. So in here, and again, I will show you. I will show you the way to do this in back in ParrotSec, all right, in Metasploit. But we see this EIP contains normal pattern at offset 146. So at this offset, after 146 bytes, at bytes 147, 148, 149, and 150, we have EIP, and then ESP. Starting at offset 150, so 140 or 151 and up, we have the rest of our pattern, and then EBP contains a normal pattern prior to EIP at offset 142. So that's the Mona way that you find an offset. But like I said, what if you don't have Mona? All right, what if you just happen to be able to do all this, you didn't have Mona set up, or maybe you're on a system that doesn't have Mona and you can't get it? Star you? No, you did not. What happens? Well, there's another way we can do this. We go here. Whoops. And actually, I'll have to go back to the documentation so you can see this part. I didn't do it. All right, so let's go here so you can see this. That's the shell code. I don't care about that. That's confirm. That should be Mona. Yeah, there's Mona. All right, so when we send this pattern, we look at this EIP 396541138, which is the equivalent to 9E88. So if we take this value and we put it 396541138 in pattern offset.rb, we're going to see where in this pattern that sequence exists, those characters. So we say okay. And we get an exact match at offset 146. So if we were to count in 146 characters, we would eventually get to that sequence. All right, so we know our offset. Cool, we found it. Awesome. What's next now that we know our offset? Well, that's where step 3 comes into play. So now that we have our offset, and we can go here, and then we want to make sure we can control EIP, EIP, and we want to send that. Am I sending my C's yet? I had C's in here somewhere. Let's take a look. I don't necessarily need them, but trigger, discover offsets, confirm. Oh yeah. So after B, I need those C's. So right after this, buff plus equals 1, 2, 3, 4. And we're going to go back here, and we are going to actually reset this again. So we're going to say, all right, cool, start over. And again, guys, if you have questions, feel free to ask them. I'll get to them. I promise. And we're going to hit play. All right. So once again, we're back at the beginning. So what are we going to do? Oh, we're going to crash this, you know, just for good measure. So we're going to save that and go here. And we're going to exploit it. Then we're going to come back to Windows 10 Flare. We broke it again. All right. So here's the question. What do we do? So let's go. My hair's a wreck, but that's okay. Let's go take a look at this script real quick and how we changed it. So instead of, well, first and foremost, what I did was I took that total length of our buffer. So we've been sending 1,024 characters. So I put that in as a variable total length. And then I put an offset in there. So we found that offset of 146. So I put that there. Then I took this and I said, all right, I want you to send. No, I do not, Cyber Panda. All right, that was an accident. Don't go there with me. Asking if I still drink mics. We'll be fighting. Yingling all day. So we're going to send A times offset SRP, which is this 146. And then we're going to subtract the length of the buffer. Well, our buffer doesn't even have a byte in it yet. So we're going to send that. And then right after that, we're going to send 4 Bs to see if we're putting that in the instruction pointer in EIP. Then we're going to send 4 Cs to make sure it's sitting on top of the stack pointer. And then the rest, because you want to equal out the length of your buffer, because you know that's how many characters it took to crash it. So we want to send and total it out to 1,024. So we're going to send the rest in D. And if we go here, we see that in the base pointer, we have A's. In EIP, we have those B's. There are 4 B's sitting right now in EIP, which means we can control the instruction pointer. We control where the next instruction is going to go. And then on the top of the stack, we have our 4 C's and 4 D's. Or in remainder D's, not 4 D's, remainder D's. So we have our entire stack here, which is awesome. So now we are controlling this. We have full control. We can do whatever the hell we want at this point, with a few exceptions. The next thing you got to do is you got to go here. So we're like, all right, cool. We have control. We control the world, but we don't. Not yet. Because before you can develop shellcode, you got to figure out what characters will not work within your code. Meaning, you send a string of characters, and whatever does not show up in the stack means that it would break your shellcode. Oh, bad charge is a bitch. I used to have a script that would do it all and spit out what was bad. I don't have it no more. I got to find it or create a new one that'll do it for me. But If I was able to transfer files backwards and forwards, I'd be able to do this with Mona. But I can't, which is fine. We're going to do this. We're going to go to here, and we're going to execute this bad character test. Alright, and then we're going to come down here. That's all the same. It's all the same. We don't want that. We want this. And let me go back to here so we can get the bad characters. Make sure. Oh, so I'll get there. Let me make sure my code's right first. Got that, got that, got that. A, B, bad character test, and then D's. All right. So this is what we don't want. Get out. My cat keeps bugging me. Apologies. All right. So, let's take a look what we have here. So, in our bad characters, we're running the gambit of from 00 to FF plus 1. However, the characters that are written in hex 00 and 0A, one's a null byte, the other one is a new line. And 9 times out of 10, those will break shellcode. You need a CLI tool for this script. So, stupid cat, get off, man. Get down. So, we already are going to exclude 00 and 0A. But the for loop that we build in will actually go through and say if this I, so if we're not in this bad charge list, then cycle through all the way up to 0xFF plus 1. And then we're going to write this test to this binary. All right. And we're going to send this bad char test. So we're going to send this variable to the buffer. All right, cool. Why not? Sounds like fun. So let's go here. Actually, let's make sure our script is running again. Or our program. And this is where do stack buffer overflow good is going to come in handy because of the way my system's not working. I would prefer to do this with Mona. That's how I've always done it. But yes, we can do this without it. So we're going to go back to ParrotSec and we're going to say exploit. Now, when we go back to here, we still have our B's. We still have our base pointer. But then we got something a little bit different. And I can see it down here. But we're going to let Justin Stevens explain a little bit. So, we already did that part. We're going to come to this part. And he says right here, we know that handle connection chunks the message we send to it based on a new line character, or alternately 0xOA. It calls do response separately for each new line delimited message we send. So because of the way the program is written, he already knows that if you send a new line, it's going to call a new do response, which is going to break what we're trying to do. So we don't want to do that. And 00 is a null byte. We don't want to include that either. So we create this for loop, as he has here. We're going to come down here. We're going to run it. And if we take this binary, we will see this exact same thing he has. All right, so it's going to go from 0, 1 all the way to FF with the exception of, so 0, 0 we know is out and 0A. And that's technically what's in the binary. But if we look at Immunity Debugger, we see, of course, we got BBB, and then we got our test string right here. So we can follow it in the dump, which makes it a little bit easier to read. We can use dash A, ESP, memory address pointed, but ESP, file name, compare, A, ESP. I don't have that binary, so I can't do it. But he tells us if you had this binary file and put it there, And you can actually have Mona create a bad char binary for you and run everything. So there's a few other scripts and people that do walkthroughs that will explain how to do this with Mona. But if you have this and you run this compare, it will tell us that everything was there. Our only bad characters are 0, 0, and 0A. So legitimately from 0, 1 to FF plus 1, everything's there with the exception of the 2 that we left out, which is cool. All right, so it means we don't have to really worry about too many bad characters. And yes, I've had to deal with scripts with like 10 bad characters that you could not use in your shellcode. So we now have our bad characters, 0, 0, 0A. So what's the next thing we need to do? Well, like I said, the point to being able to control EIP is to be able to tell your code, tell the program where you want it to go. So if we're able to write everything all the way to the stack in our stack pointer, then flags and R is very easy. Yeah, very easy, Cyber Panda. Very easy. Let me tell you. So we take it and we put jump ESP. We need to find a jump ESP that doesn't have bad characters and doesn't have like ASLR or DAP or anything like that. So we need to find that location in memory and put that in EIP. So without me going through and rerunning this a ton of times, we're going to go down here and we're going to find the Mona command that will actually find this jump ESP for us. So right here, this Mona command is actually going to find jump ESP where these bad characters are not included. So we come here and we run that. And with it, we've got 2 pointers. And we'll go back to the PDF just because it shows it here. 080414C3 and 080416BF. It doesn't really matter what we use. I'm going to use the same one he did, which if we come over here to this code, it's going to be this 080414C3. So that's going to be our pointer to jump to ESP. All right, Fomat, have a good one, brother. So we go here. We have this pointer jump ESP. And we're going to put that in our code. Now, I'm not going to go back. I'm actually going to break into this because I'm about out of time anyways. So I want to finish this up. This sub ESP10. Anybody who does buffer overflows for the very first time, you'll hear a lot about NOP sleds. What Justin Stevens explains in his documentation and has yet to fail me when it comes to buffer overflows is you don't have to worry about the number of NOPs or doing a NOP sled. If you subtract 10 from ESP, every time I've run a buffer overflow, this has worked and allowed me to execute whatever shellcode I put in there. All right, so we know we need that. And then we no longer need these B's. Well, because I don't care about B's. We will leave that there. And then we want that. And the next thing we want is this. Well, what the heck? All right, we want our shellcode. Now, I'm going to do something fun. And I'm hoping this shellcode works. Because if not, I'm going to be a fool. But we're going to give this a shot. Windows. Meter reverse TCP. And so we're going to use MSF Venom to write a payload that's going to listen on port 4. My listening port is going to be 4444. My host is 135. We're going to have these bad characters, so those aren't going to be included in the shellcode. I'm writing this for Python, and my variable name is going to be shellcode reverse. So when I execute this, and yes, I'm doing Meterpreter just because I started out explaining Metasploit, so why not have some fun with Meterpreter? And even though I'm on Windows 10, I'm really hoping this goes without failure. So we're going to copy this. And like I said, because I'm at the end of the lesson, or already over time for what I normally want, what I want to do, and while you're on, if you want to support, I do have Patreon. I have buy me a coffee, well, buy me a beer. I have CyberWarriorStudios.com where you can get merchandise, and I have PayPal and CashApp and everything else. So if you're on YouTube, everything's always in the description. If you go to CyberWarriorStudios.com, you'll see everything there. And on Twitch, I believe I set up for donations, but I don't know if they work. Who knows? But if you want to support me, those are all the ways you can support. Or as always, share, subscribe, follow, alerts, let people know about me. That all works too. So now, so we have that saved, and we're saying we're going to run a Meterpreter shell. So here we are. Use exploit multi-handler. Set set payload. Payload. Come on. Windows. Alt plus shift. Hey, don't judge me. Interpreter. Reverse TCP. Show options. Set L host 192.168.1.1.5. And run. Alright, so we got our reverse handler running. So now, let's validate that we are running on here. And we're not. So, let's rerun. Last time that I did this, I set it up with Netcat. It was just a standard reverse shell. But like I said, since we're using Metasploit, we're going to have some fun. And hope that this works for me. So we're going to go over here to our bash shell. And we're going to say exploit. Then we're going to come over here. Meterpreter. So, like I said, Meterpreter is allowed once on your OSCP. I do like it for pen tests, and if you have MSF Pro or anything like that, then you can do a lot more things like arbitrage. There's a lot of things you can do with it. But essentially, I can sit here, I can run shell, and I'm now on the computer. From Meterpreter, I was already in shell, so we can say exit and do load. I think it's load. Mimi. Kiwi. Now, even though my system's completely up to date, I still have Kiwi on here. This probably won't work, but we're gonna give it a shot. No, I can't get system, which is fine. But yes, I have Kiwi. So if you're using like Mimikatz, Meterpreter, and we can get into lessons about Meterpreter later. If that's something you want to see, please feel free to let me know in comments if you're on YouTube or in chat. Look, I've even got chat for my channel itself, so if you want to send a message in there, I will receive it, I will respond, and we can make it happen. Now, other than that, look guys, I love you, and I love doing this for you. I couldn't be here without you guys, so any support, any shares, any subscribers that you can get would be amazing. Whatever you want to see next week, please let me know. I love ParrotSec, so I will be digging and trying to figure out different things to show you. And other than that, I think you guys should have a fantastic rest of your night. And once again, I'm Cyber Warrior. This is CyberWarriorStudios. It's Tech Tuesday, and I hope you enjoy the rest of your week. Oh, real quick, don't forget to tune in Friday night at 10 p.m. Eastern Time for Security Happy Hour, where I will have InfoSec Sherpa and another gentleman. So make sure you all tune in for that. And I'll see you all next time.